try to solve a Leetcode problem 494, target sum. So we are giving an integer array nums, and we are also giving an integer target, and we can turn this nums with a positive or negative. It means we can add a positive sign or negative sign just before each of the integer inside of the nums. And finally, we just need to calculate the sum of all the values after we add this minus or positive values. So for example, this one add a minus, and for others, so this one is a positive, 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 positive. And for example, here will be a minus, and for other examples, you can see here and here. So in total, there will be 5 different ways. So we just need to check how many different ways to combine the sum of the nums to the target. But we can add positive sign or negative sign or each of the numbers. So if you analyze this problem, basically, for example, if there's no negative sign, it is always positive. So it is like the it is exactly like the target sum. So for example, we just need to find 3 numbers, which is the sum of them would be 3. Like 1, 1, 1, or maybe this 1, 1, 1. So in total, there will be 10 such a result. But for our problem, we can add negative values. It means this value can be negative or other values can be negative. If we didn't add the negative sign, so this is a typical knapsack problem. It is a typical 0-1 knapsack problem. It means for each of the numbers, you can choose it or you can't choose it. So for example, if you choose this number, and then if you choose this number or this number, you choose the first 3 numbers, and the sum of them will be 3. So currently, I'm just analyzing without negative sign. And then maybe we choose these 3 values. And the target sum is 3. So this is a 0-1 knapsack. The 0-1 knapsack. It means that you can choose this value or not choose, but you can only do one time. It means if you choose this value or not choose, and after this time you cannot do this again. Otherwise, it will be complete knapsack. But for our problem, it is a 0-1 knapsack problems. Let me explain the knapsack problem and then go to the coding to finish this problem. Even we have negative sign, and it is still a 0-1 knapsack problem. For each of the numbers, we can use a negative sign, or we will not use a negative sign. And for each of the numbers, we can do all of that, and it's gonna be the same. We just need to check the sum of all the values equals to 3 or not, and we're gonna check how many of them. So this is a typical 0-1 knapsack problem, and I think that explanation is enough if you know about 0-1 knapsack problem. Let me first start coding, and then analyze the difference of the typical 0-1 knapsack and for this problem. This problem is just a little bit changed to the 0-1 knapsack. So I'm gonna use prepare a function. So inside, I'm gonna prepare a t. So this t is for the target. So this t gonna start from 0, and I'm gonna prepare an index. Index is also 0. So finally, I'm gonna call this function f with 0 and 0. So it means the target from the beginning is 0 and the index is also 0. Now, I'm going to check if this I equal to the length of nums. So this means basically I've already go out of the array. So for each of the numbers I've already checked. But for next time I will go out of the array. So if I go out of array, I need to return something. So this is the boundary case. So I need to return a value. But this value is dependent on this t. So this t can be equal to target. And it cannot be equal to target, and we are not sure. So if this t equal to the target, we're gonna return a 1 because we find one solution. Otherwise, we return 0. It means we didn't find. So we're gonna return 1 if this t equals to the target. Otherwise, we're gonna return 0. And now let me return what is the meaning of this t. And this t is just the target from the beginning. It's gonna be 0. Yeah. So it's gonna have two solutions. So for each one, yeah, we may choose a negative value, or we may choose a positive value. If we choose a negative value, it means it's gonna be add a negative sign. Yeah. So from the beginning, we have this t. So the t, if choose a negative value, what is it gonna be? It needs to minus this nums. So it's gonna be nums I. Yeah, if I minus this value, so what is my index? It means I need to go to the next number. So the index would be I plus 1. Yeah. And I also can choose a positive value. Yeah, if it is a positive value, basically this t will plus nums I. Yeah. So it would be plus f t plus a nums I, and with I plus 1. Because for the next number, it will always be I plus 1. But from here, this t plus or minus, it is always dependent on our selections. If we choose to have a positive value, it's gonna be plus nums I, because t is 0, maybe plus nums I, maybe it becomes 1. Yeah. Or we can also decide to use a negative value. Maybe this is a negative 1. Yeah, so the t minus this value, from 0 minus 1, it's going to be negative 1. Yeah, so that will be all the different solutions. Yeah, now let me run it to check if it works. Yeah, as you can see, it works. But what if I submit it? I will get a time limit exceeded, because this t and I gonna be a very, yeah, because we have t and I, and this is just DFS, and it's gonna be time limited because it is a 2 to the power of t and I. Yeah, t times I. But yeah, in order to optimize the solution, we need to optimize it by using a case. So in Python, we can use a case directly. So if we add a case, it means the time complexity would become t times I. Yeah, because there are only 2 variables inside, and everything will be stored in memory. So we don't need to check it again, because in memory it's just 1. So the time complexity would become t times I. Now let me submit it again to check if it works. Yeah, as you can see, it works. And the speed is okay, because this is not a tabulation DP. So this is just memorization. Basically, it's gonna be a little bit slower. Yeah, but this is gonna be the starting point to solving knapsack problem. I think this is gonna be easier to understand. Yeah. Now let me go back to the 0-1 knapsack template and our target sum problem. Yeah. So for the 0-1 knapsack problem, actually, yeah, for the problem we have a value array, and we also have a weight array. So we have the value and weight. So this is the typical 0-1 knapsack problem. And we also have this t. So this t is the target, or the total value, and this I is indexed from 0. Yeah. So for the 0-1 knapsack problem, actually, yeah, we want to put into the knapsack with a limit. For example, this limit gonna be a t. The total maybe 20 kilograms. We can at most put 20 kilograms, but we need to get to the maximum value. And this value is inside a value array, and we also have a weight array, so everything is inside. So here is the template. If I equal to the length of the value or the weight, yeah, we're gonna return 0. It means, yeah, we just need to return a 0 because it goes out of the boundary. We've already checked everything. Yeah, if this total value is less than 0, so it means the bag cannot hold any weight. Yeah, the knapsack cannot hold any weight, so we need to return a negative value. It's gonna be the negative infinity. Otherwise, we're gonna choose the maximum of the 2 possible results. So if we didn't choose it, so I plus 1 will go directly. Yeah, if we decided to take an item, so we're gonna take this item. If we take this item, the total value will be minus this item, and we still go to the next item. Yeah, but our final result need to plus this value. It will be vi, because we already take this item. It will be inside the knapsack. Yeah. So this is a typical knapsack template. And after you understanding this template, yes, you're gonna use this template to solve all the 0-1 knapsack problem. So for example, this one. Yeah, we just need to use a cast. And for this template, actually we can also use a cast, because normally we can take this v and w outside the f function, because this will be given by the problem. Yeah. And now you can see here, it's gonna be basically the same. For here, we just need to check if it is equal, we're gonna check the result. Yeah. Otherwise, we have two solutions. We need to plus, we need to like f1 plus f2, because we need to check all the different solutions. And for this one, we're gonna check the maximum value, because this is the template. Yeah. Now let me go back to the code editor to summarize it. Yeah. And that is all about it. And we can check that nums length and this nums I, it is 1020. It means 20 times 1000 is not a big value. That is why it can pass for Leetcode. Thank you for watching. See you next time.